All right, everyone. Today we're going to talk exponential functions and their graphs. This is Hrs Algebra 2. I am live during period 3. Just as a reminder, if you'd like to ask questions, you're more than welcome to, but it'll be on the video. If not, then you can always save them until after. Today we're not going to go through the full set of notes. We're only going to do, I believe, 4 examples. We're going to talk about the properties of their graphs, and then we're also going to talk about exponential growth and decay. So let's kind of get into what we're doing here. Properties of exponential functions. The big thing that you have to realize is with an exponential, it's not necessarily that you're just multiplying, but you're multiplying by the same number consistently over time. There's 2 different formulas. That one that I've highlighted there, y is equal to a times b to the x, is the main one that we're going to work with. I think it's the better one of the 2. So let me kind of talk just for a minute about what those are. A is your initial starting value. So whatever they give you in your problem, be it bacteria or some other type of milligrams that are associated. A lot of it is more science jargon that we'll do with the word problems. That's going to be what you initially start with. You always start with 100% of what you have. That's important, because your B value is then going to be based on your multiplier and whether or not you are growing or decaying. So if you take a look at this next slide here, it talks a little bit about your B value. B, if it's greater than 1, it's called a growth, and we'll add it to it. And if it's less than 1, it'll be called a decay. Your X value is usually the time frame. Sometimes they just specifically give it to you. Other times you kind of have to figure it out. So follow along. Example number 1 is actually 2 different problems. Anytime that you do problems like this, you're going to use the same A and B value. It's just the X value that will mainly change. And then we're going to have to find those out. Again, ask questions along the way if you have them. The population of Brazil was about 162,661,000 in 1996 and was projected to grow at a rate of about 7.7% per decade. Predict the population to the nearest 100,000 of Brazil for the year 2021 and 2027. So first, I'm going to break this into 2 different problems. One of these is going to be for the year 2021. And the other is going to be for the year 2027. We are going to use y is equal to a times b to the x for our formula. It's the exponential formula, regardless of whether we're doing growth or decay. I'm going to reread through some of this so you kind of know where I'm pulling things from. That'll help give you a little bit of context clues to whenever you're solving. The population of Brazil was about 162,661,000. That's your starting value. That's going to be your A. In 1996, was projected to grow at a rate of 7.7% per decade. So grow. So when we talk grow, that's in 7.7%. That's going to be our B value. So how we figure out a B value? You always have 100% of what you start with, meaning that I started with 162, million people. Okay, I started 100% off the board. I'm adding to that 7.7%. I'm growing it out. So we're going to change those to decimals, moving them 2 spots. So in this case, 100% is going to be 1, and 7.7 is going to be 0.077. So B value is going to be 1.077 for my equation. When it says grow, you add to 1. When it says decay, you subtract from 1. Okay? Per decade, And then it says population to the nearest 100,000 to Brazil for 2021 and 2027. So let's find our x. For 2021, our x value. We want to get to 2021. We started in 1996. $25 years in between. We want to divide this by 10 because in the problem it says per decade. And decade means 10 years. If we left it at 25, it would assume that it grew at that rate every single year. This is telling us it grew at that rate per decade. So our x value in this case is going to be 2.5. We now have enough information to do the first problem and enough information to make the second problem easier. Okay. So I'm going to plug everything that I have into that formula. Y is equal to 162,661,000 times 1.077 to the 2.5. We're going to plug that into our calculator. $1.077 to the 2.5 times 162,661,000. And rounded to the nearest 100,000, I'm looking at 195,800,000. I think the actual answer was 804,512, and then people. How this sets us up for the second problem is A and B are the exact same. We just have to figure out what our x is going to be, doing the same exact thing. So x in this case, 2027 minus 1996 gives us 31. Divide by 10. Because it says decade, if it didn't say decade, we wouldn't do the dividing. And then we can plug it into our equation. Now, on the video, if you hear any background noise, it is raining pretty heavily here. Got to preface that. Double check your work. Make sure it's the same as mine. If you got something a little bit different, we can talk. But questions at all? How to find growth? Okay. Yep. Yeah, I rounded to the 100,000. Yeah. Yep.
Do you want the exact answer on the test?
All depends on what it asks for. Yeah, I'll let you know. On an exam, I'll let you know what it is. All right. So growth you add, decay you subtract. So here's a scenario. Okay, I start with 10 items, and I have a 20% decrease. After a year, how many are left? If I had 10 items to start and I have a 20% decrease, after 1 year, how many are left? 8. Okay, you take the 10, multiply by 0.8. Okay, so that's very similar to example number 2. Decay is where your B value is between 0 and 1. And here's what we've got for example number 2. A vitamin is eliminated from the bloodstream at a rate of about 20% per hour. The vitamin reaches a peak level in the bloodstream of 300 milligrams. Predict the amount to the nearest tenth of a milligram of the vitamin remaining 2 hours after the peak level and 7 hours after the peak level. So it's asking me 2 problems. It's asking me the 2 hours and the 7 hours. A value is what I start with. Started with 300. My B value, it says it's eliminated, so that's a decay. If I started with 1 or 100% of something and I took 20% away, 0.20, and end up with 80% left. The X value is, they give it to you in this case. It's 2 hours and then 7 hours after the peak level. Peak level just means that where it started at 300 milligrams. So let's plug in the first one here. Y is equal to 300 times 0.8 to the second power. Verify getting 192 milligrams. Yeah, okay, awesome. Got some people shaking their heads. It's a good sign. And then the 7 hours. Getting a reading here of 62.9 milligrams. It says to the nearest tenth. Yay? Yeah? Good? Good? Okay. All right, so there's growth and decay. Questions at all on those? We're going to move on to the second part of this lesson, and then we'll pretty much be done for the day. It's just the graphing. I just want to show you some stuff with the graphs. Good? All right, let's keep moving in the video. Next part is just graphing of exponential functions. I want to show you a couple different features of these. We're mainly going to work in this class, if you take a look at an exponential function, mainly going to work with things that are just going to go either up or down. I just kind of want to show you the shape and then some of the characteristics of those. There's no like, oh, one side's going to go up and one side's going to go down and one side's going to go up and down. It's all just either one half curve or down or up. So in order to do this, I'm going to ask everybody to just kind of start off with an XY chart. In this X values, we're going to do 2 negative numbers, the neutral number of 0, and then 2 positive numbers. Mainly because I want you to see the curve, see what's going on. So I'm going to plug each of those into my equation. So 2 to the negative 2 is 1/4 times 5 gives me 5/4. 2 to the negative 1 is 1/2. So times 5 is 5/2. 2 to the 0 power is 1. Times 5 is 5. 2 to the first, 2 times 5 is 10. And 2 squared is 4 times 5 is 20. So, -1, -2, 2, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, and so forth. -2, 5/4 is going to be right about there. Oh, it's going to be right about there, -2. And then 2.5 and 1, 2, 3, 4, 5. I scaled this a little bit so you could see it a little better. 6, 7, 8, 9, 10. And then 20 will be somewhere up in the clouds. Couple things that I want you to note before we move on to the next one. First off, this B value, when it's greater than 1, it's a growth. Growth always look like this, where they start down and then they'll go up exponentially. Second thing that I want you to know is that there's actually a horizontal asymptote here. It's always where your number out here would be. In both of these examples, it's going to be plus 0. I honestly don't remember moving forward, okay, if we change that a whole lot, where it's any other number. But I just want you to know, since there's nothing out there, it's just, that's where technically, if you were to look, you would have what they call horizontal asymptote here. It's mainly that when you go down exponentially, you'll get closer and closer. You'll like have, so 5/4, and then it'll go 5/8, I think it is, and then 5/16, and then 5/32. You'll never actually reach 0. It'll always just be like a continual fraction leading to it, approaching it, but you'll never actually get there. So that's kind of something interesting about it. Your domain and range. So if you looked at this and said domain and range, your domain, in this case, -infinity to positive infinity. And then the range would just be from 0 to infinity. Okay. Without touching 0, so it'd be in a parenthesis. Again, I don't really remember if we do a whole lot with that, though. I think that's more of like a skill for the next level. All right, so this is growth. I'm going to move on to decay. I want you to do the same exact thing. Do an XY chart, -2, -1, 0, 1, and 2. Find those points, plot them. Okay. ½ to -2 is going to be 4. So that's going to give you 160. 1/2 to the -1 is 2 times 40, give you 80. 1, so that'll be 40. 1/2 times 40 is 20, and then 1/2 squared is 1/4. Divided by 40 is 10. One, two, two. Let's do. I'm gonna go by tens on my scale. Up, at least. You can go by whatever you want to. I just think that'd be easier to see, so forth. So -2 will be way, way up here at 160. -1 is 80. 0 is 40. So forth. So there's what your graph looks like. Okay, so again, some things to remember here. This will never actually hit 0 in this case. It'll approach it like if you take 3 there, then you're dividing 40 by 1/8. It gives you 5, and then you just keep going lower, but you'll never actually hit 0. It'll just start to become fractions. This right here, this number, it's between 0 and 1. So your b value, so this is why this would be a decay. Your domain, still negative infinity to positive infinity. And then your range in this case just goes back. Your range is still going to be 0 to infinity. Okay, looking from bottom to top. Even though it looks like it's backwards, it's coming from 0, or it's going from 0 up. Okay, and then that's pretty much the graph there. Okay. Questions at all? Yes. All right, I'm going to stop the video.